So I'm making a water break for my dyno. I have all the parts cast, but unfortunately the last casting for the rotor didn't turn out so good. One of the parts of the sand mold fell out, as well as I didn't use a core for the center section where the shaft goes through. And the section was just too thick, and I didn't have a riser on it, and there was a whole lot of shrinkage, as you can see in the picture here. So next time around, I'm going to use a core to create a volume through the center where the shaft goes, and that'll make the cross section a little smaller, and hopefully I won't have as bad a shrinkage. So here you can see I'm 3D printing some PLA plastic core boxes for that center core section. So for the core boxes and patterns for sand casting, which are basically molds, you really want a nice smooth surface so it pulls off the sand nicely. What I've found is 3D printing, has a lot of lines on it, and what I found works well is to use a body filler. Your typical body filler, like Bondo, is pretty hard sanding. So what I've actually found works pretty well is glazing putty. It sands a lot easier. So I'll go through and I'll smear a bunch of glazing putty all over the surfaces I want smooth, and give them a quick sand, and then shoot them with some primer and or paint, and that leaves me with a pretty good surface in a pretty minimal amount of time and effort. Here I'm using body filler to add a little bit more draft angle to the main pattern, because the last time I did the casting, the pattern didn't pull out very well out of the sand, so this should help improve it. So what I'm making here is are the sand cores. I've got 85 grit silica sand. Got 30 ounces of that. I'm going to add sodium silicate. This is going to be mixed at 4% by weight. Okay. I'm going to mix that up good. And I found if you don't mix this up real good and there's any kind of clumps in it, it'll really want to stick to your mold or your pattern or whatever you're using. Alright, so what I'm going to use, what I got here is, it's called Zip Slip. It's a mold release for foundry work, and it just works phenomenally well. You can use all kinds of other things and powders and dusts, and that's what this is powdered lime. And it works pretty well, but there's nothing more frustrating than your stuff sticking. And this stuff just works great. Okay, so I got my sodium silicate sand mixed up. I've got my core box ready to go. I've got some aligning dowels here. 2 halves. Put them together. Packet full of sand. So there's a couple different ways you can use sodium silicate. I want to say I think you can bake it. You can also add chemicals to it, and it'll set up during a certain amount of time. Or you can set it up with sodium silicate, or excuse me, CO2 gas. So what I'm going to be doing today is the CO2 gas method. Okay. So that's all packed up. It'll last for a while if you keep it sealed up. Basically, you don't want it to dry out. As long as it doesn't dry out, it should be good for the next time you want to use it. Get all the air out of there. Okay, so what I got here is a CO2 cylinder, and a regulator, and a hose. And I'll basically just inject CO2 gas. Turn the regulator up a bit. I've only got it at like 5 psi or something. Alright, that's pretty much set up. I'll let it sit here for a little bit for good measure. Okay, let's see if she opens up. Take these pins out. There we go. There's the sand core. So now let's go ram up the sand for the main pattern. So I just got done adding flux to the molten metal, and next you're going to see me bubbling argon into the molten metal actually. And what this does is it helps release any dissolved gases. Any moisture as well as some other conditions will incorporate dissolved gases such as hydrogen into the molten metal. And this is a bad thing because when the metal solidifies, you'll be left with voids and porosity, which is definitely not a good thing. So I've got a argon welding gas bottle with regulator and a hose, and I've got it hooked up to a stainless steel tube with a plate at the bottom, and I insert this into the crucible and all the way pretty much down to the bottom in the molten metal, and it basically bubbles all that argon gas throughout the molten metal, and it helps disturb any dissolved gases, and they float out to the top. So next I'll skim all the dross off the top, and then I'll check the temperature. I've got a K-type thermocouple fixed to a pole, and I'll read the temperature by directly dipping the thermocouple in the molten metal and make sure I'm at the temperature I want to be. I believe this one I wanted to pour at 1200 degrees Fahrenheit, a bit on the lower side due to the thick cross-sectional area of the part. Thinner parts you'd use a bit higher temperature.
Okay, which side do you want? Whatever. You take that side because I got the port control. Okay. And then you see where we're going? Yeah. Right here. And then we'll put the excess in there. Ready? There might be some flames, it'll be okay. Okay. worried about it losing metal. Like, it's okay spilling, it's not going to hurt anything, but...
I thought you weren't going to have enough for a sec.
Yeah, me too. Cool. That should work.